Yes. Today I will explain you about the important LAQs which are important for your next examination. So those LAQs you know that from question number 19. 19, 20 and 21. These three are the LAQs. So I am giving in 1:3 ratio in these LAQs among these three. You see that in the question number 19 I am giving two important LAQs. Those are important. First one, in the 19 LAQ, absolutely. Yes, in the 19 LAQ, one is the important one, that is the collusion theory. Collusion theory. And the next one is ऐड मिला के लिखना। इसमें 19 में जनरली ए और बी बिट्स बल के पूछते रहते बेटा। So A1 is the write the postulates in the collusion theory, and the second one is from the electrochemistry explain about the galvanic cell. So this is the expected question. In this also I am giving this LAQs in 1:2 ratio. This is the one expected 19th question, and the second one is write about the Colroche law and its applications. Colroche law and its applications. Next, in this, write about the order and molecularity. So this is another question. So these are the two important expected questions in your exam. So in this question number 20, I am writing some questions. See this. In the question number 20, first one is write the preparation of ammonia. Write the preparation of ammonia by Abbott's process. And the continuation, how it reacts with these reactions are there. ZnSO4, CuSO4, AgCl. This is the one important one. And the second question in the 20, write the preparation of ozone, or how ozone is prepared. Write the preparation of ozone and how it reacts with the following. In that some properties are given, PBS, KI, and another one how it reacts with the mercury and how it reacts with the C2H4. This is another question. भाई जरा निकालना है, नीचे करना है. In the 20th only, next question is how Cl2 is prepared by electrolytic method, and how it reacts with the following. In that, first one is a reaction with water H2O, and second one a reaction with NaOH, and the third one that is given that reaction with ammonia. So so this is the next question in the 20th one. These are the some important expected question in the question number 20, and in the question number 21 all name reactions are given. I am writing one by one. First one is Coles reaction, and second one is Riemann reaction, and third one is Williamson synthesis. The fourth one is aldol condensation. Next name reaction is Cannizzaro reaction. Next one is decarboxylation acetylation. इतने नहीं पूछता इसमें, कौन से भी 3 या 4 पूछ लेता. So this is about the important 21st LAQ. So today I will explain you one by one. I think question number 20 is over in previous classes. So once again I am revising that question number 20 in short. Listen to me. In the question number 20, the first question is how ammonia is prepared by Haber's process. I am explaining you about the Haber's process. How ammonia is prepared in the Haber's process. In the Haber's process, ammonia is prepared by the direct combination of the nitrogen with the hydrogen. This is the principle in this. N2 combined with the H2, a reversible reaction, 2NH3. See here, in Haber process, ammonia is prepared by the direct combination of N2 and H2, which we are taking in how much ratio? 1:3 ratio. And you have to remember this is the exothermic reaction. So kilojoules per mole. You have to mention this thing that to get the more quantity of ammonia, so we have to follow the Le-Chatelier principle. So to get the good yield of the ammonia, you have to decrease the temperature during the reaction and you have to increase the pressure during the reaction. What are the favorable conditions for the formation of ammonia? That is the first one, you have to maintain the temperature. Low temperature is favorable, but at low temperature reaction is very slow. In the Haber's process, this temperature 725 to 775 kelvins are used. And the second favorable condition about the pressure. How much pressure is used? Generally 200 and above pressure is used. 200 to 300 or 1000 atmosphere pressure is used during the preparation of ammonia in Haber's process. This is about the principle in the preparation of ammonia. Once again I am repeating. In this process, ammonia is prepared by the direct combination of nitrogen and hydrogen in 1:3 ratio. And the formation of ammonia is a reversible exothermic reaction. Therefore, for the good yield of ammonia, low temperature and high pressure is recommended. Here I am written that pressure and temperature condition. So, but at low temperature reaction is very slow, therefore optimum temperature and also catalyst is used. You have to write the names of the catalyst also. In this process, a mixture of K2O and Al2O3 is used, or iron is also used. So this is about the principle in the preparation of ammonia. Now see the procedure how ammonia is prepared. For the procedure, I am explaining you. So we are taking this N2 and H2 gases in 1:3 ratio. Principal diagram I am drawing it here. So this is the one provision. This is for the H2 and this is for the N2 and H2. There are two provisions are there, which we are taking ammonia and nitrogen in the ammonia and nitrogen in the 1:3 ratio. So N2 and H2 we are taking in 1:3 ratio, and these are the compressed, these two gases are compressed well in the compressor chamber. So first we are taking the N2 and H2 mixture in the 1:3 ratio, and these are compressed well in the compressor chamber with the help of the compressor. Now then these compressed gases are passed into the beside chamber, that is called as the catalytic chamber. Here catalytic chamber is there. So this is the catalytic chamber. So these compressed gases are passed into the catalytic chamber. In this, a mixture of K2O and Al2O3 acts as the catalyst, and the temperature of this catalytic chamber is maintained about the 725 to 775 kelvins. In this catalytic chamber, a reaction of N2 and H2, reaction between N2 and H2 takes place. There is about 10 to 15% ammonia is formed in this chamber. So to separate this, in this catalytic chamber, reaction between this N2 and H2 takes place, and then about 15% ammonia is formed in this chamber. To separate this NH3 from the unreactable gases, you know that some N2 and H2 gases are also left in this. To separate this ammonia from this N2 and H2, this gas mixture is passed into the condenser chamber. This is the condenser chamber where cooling pipes are present. So this is the condenser chamber where NH3 get liquefied and it is collected. Here ammonia is there. It is easily liquefied and it is collected. Now then these unreactable gases are again passed or pumped back for the recycling purpose. At here reservoir is there. By means of this, these are again passed back for the recycling. Once again I am repeating this procedure. In the preparation of the ammonia, first we are taking N2 and H2 gases, and these are compressed well in this chamber. Now then these compressed gases are passed into the catalytic chamber, where the reaction between reaction between N2 and H2 takes place. In this catalytic chamber, a catalyst is a mixture of K2 and Al2O3 is present, and the temperature of this chamber is maintained between 725 to 775 kelvins. In the presence of this catalyst, at this temperature, reaction between N2 and H2 takes place. About 15% ammonia is formed. To separate this ammonia from the unreactable gases mixture, this gases mixture is passed into the this chamber, that is called as condenser chamber, where ammonia is liquefied and it is collected, and remaining unreactable gases are passed back for the recycling. This is about the preparation of ammonia. Now then properties of the ammonia. How ammonia is reacts with the following. Some reactions are given. Which are those reactions? First one, how it reacts with the zinc sulfate, ZnSO4. Ammonia reacts with the zinc sulfate solution. Ammonia, zinc sulfate reacts with the ammonium solution. This is the ammonium solution. When ammonia is dissolved in water, you will get the NH4OH. You see that this is the reaction. So you have to take the 2 moles of NH4OH. Ammonia solution, that is ammonia is reacts with the zinc sulfate and gives the precipitate. Which precipitate is formed here? This reaction is takes place. Simply you combine the zinc with the OH, zinc OH se milta, NH4 इससे मिलता. As a result of that you will get the zinc hydroxide precipitate. This is the dirty white color precipitate, zinc hydroxide, and the remaining is you will get this ammonium NH4 taken to SO4. So this is about the first reaction. Ammonia solution reacts with the zinc sulfate and forms the precipitate, zinc hydroxide precipitate. This is the first property. And the second one, how this ammonia reacts with the copper sulfate, CuSO4. This is the copper sulfate plus I am taking the 4 molecules or 4 moles of Na3. This is the stoichiometric ratio. So copper sulfate reacts with the 4Na3. At here blue colored complex is formed. Just you insert the ammonia between this and this, you will get the product, that is this product CuNH3. How many times I am taking? 4 times. Therefore taken 4 times, this is complex. Therefore this is the complex form. This is the blue colored complex is formed during this reaction. When ammonia treated with the copper sulfate, that gives the deep blue colored complex. So this is the second property. And the third one which is mentioned, that is the reaction with what? AgCl, silver chloride, AgCl. AgCl reacts with the ammonia. At here I am taking the 2 moles, 2 NH3 gives rise to here also white color complex is formed, AgCl plus 2 NH3. इन दोनों के बीच में आप NH3 को लगा दीजिए. Once again I am writing complex ऐसा Ag लिख लेना. फिर now next one NH3. How many times? 2 times. Now close the bracket. This is the complex and Cl. So these are the properties of ammonia. Once again I am repeating. Ammonia solution reacts with zinc sulfate and gives the precipitate. Copper sulfate reacts with the ammonia and gives the blue colored complex. You know that ammonia is a good complexing agent. It donates its lone pairs to the metals and form the complexes. Ammonia combines with copper sulfate. At here complex is formed. What is the color of the complex? Blue colored complex is formed. It reacts with, that is ammonia reacts with AgCl and forms the complex. White colored complex is formed. So this is about the first important LAQ, that is frequently asked in the question number 19. 19 में LAQ ज़्यादा पूछता preparation of ammonia के बारे में. Next LAQ question number 19 में second important LAQ, second one is this one. How ozone is prepared? Write the preparation of ozone preparation and how it reacts with the following. बोल के पूछ रहा हूँ. Preparation of ozone. I am explaining you about the preparation of ozone. You know that ozone is prepared from the oxygen only, O2. Now then what is the formula of the ozone? Formula of the ozone is O3. So see here, ये 3 को इधर डाल लीजिए, 3 O2. नेक्स्ट ये 2 को इधर डाल लीजिए, ऐसा कंबाइन करिए. व्हेन ऑक्सीजन इज सब्जेक्टेड टू द इलेक्ट्रिक डिस्चार्ज, ऑक्सीजन को इलेक्ट्रिक डिस्चार्ज करे, इलेक्ट्रिसिटी पास कर लिए. whenever the electric discharge is passed to the through the oxygen, when oxygen is subjected to silent electric discharge, some part of the oxygen is converted to the ozone. So this is about the principle. So you know that this is a reversible reaction and it is a endothermic process. According to the Le-Chatelier principle, for the formation of ozone you have to use high temperature, and you have to mention clearly at here it is the endothermic. Therefore high temperature is favorable for the formation of ozone. So another thing, the instrument which is used for the formation of ozone is called as the ozonizer. It is called as ozonizer. Instrument which is used for the preparation of ozone is called as ozonizer. Once again I am repeating, ozone is prepared from the oxygen only. In the principle you have to write like this: whenever the oxygen is subjected to the silent electric discharge, some part of the oxygen, not totally converted, some part of the oxygen is converted to the ozone. So as a result of this, a mixture of O2 plus O3 is formed, that is called as ozonized oxygen. That is called as what? Ozonized oxygen. Formation of ozone is the endothermic process and reversible process. You have to remember, you have to write this also. And the instrument which is used for the preparation of ozone is called as ozonizer. This is about the preparation of ozone. Now next, properties of ozone. Ozone के properties बोल रहा हूँ मैं. So how it reacts with the following? Among that, first one, ozone reacts with the what? PBS, lead sulfide. It is the black colored substance. Ozone reacts with the lead sulfide. At here, what is taking place? Just what is going on? Just you check it out. So I am taking the 4 moles of the O3. Lead sulfide is oxidized to the lead sulfate. PBS जो ले अपन ऐसा डाल ले रहा हूँ, PBS 4O3 को ऐसा यूज कर ले रहा हूँ, O3, इसमें से एक एक ऑक्सीजन, इससे एक ऑक्सीजन सल्फर को आ जाता. As a result of that, PBS is converted to what? PbSO4. Lead sulfide is oxidized to the lead sulfate. PBS plus 4O3 gives rise to PbSO4 plus, and what is left? 4O2 is left. This is about the first property. In this reaction, black colored lead sulfide, you have to write this, lead sulfide is oxidized to the lead sulfate. This is about the first one. Ozone oxidizes lead sulfide to lead sulfate. The second one, how it reacts with the potassium iodide, Ki. You have to take this potassium iodide in moist condition, H2O. This is the reaction, 2Ki plus H2O plus O3. Okay, ozone reacts with the potassium iodide and forms and liberates iodine. ये iodine को release कर रहा, 2Ki plus H2O plus O3. As a result of that, you will get the 2Ki की जगह 2KOH लिख दो. अब दोनों iodines मिलके यहाँ पे I2 आ जाता and the remaining is the O2. So this is the reaction. Potassium iodide is oxidized to the I2. It is also oxidation property because in the Ki oxidation state of the iodine is -1. In this oxidation state of the iodine, right side is 0. So -1 से 0 हुआ, so Ki oxidized हुआ. So this is the second property, potassium iodide is oxidized to the iodine. And the third one, how it reacts with the mercury, Hg. This is the shiny white colored liquid, silver colored liquid, and does not sticks on the glass tubes. कहीं भी ये नहीं चिपकता. mercury white color का shiny liquid है, meniscus liquid है. When ozone is passed through the mercury, इससे ozone अगर पास कर लिए ग्लास ट्यूब में, मैं ये ले लिया, कंटेनर में ले लिया, mercury ले लिया, तो mercury के साथ में मैं क्या कर रहा हूँ? O3 को react कर रहा हूँ. When O3 is passed through this mercury, it loses its properties. उसके properties से ले आते, O3 से पास कर लिया मैं, तो इसके properties, इसके जो भी properties से चले आते, mercury क्या बनता? mercurous oxide, Hg is converted to the Hg2O and oxygen O2 is liberated. That means when O3 is passed through the mercury, it loses its properties and sticks on the glass tube. ये test tube के walls को चिपकना शुरू, चिपक जाता. So this is the property called as the tailing of mercury. Tailing का मतलब चिपक जाना, stick हो जाता, sticking of mercury or tailing of mercury. When ozone is passed through the mercury, mercury loses its properties and that sticks on the glass tube. This is called as the tailing of mercury and it is the important VSAQ for your examination. What is tailing of mercury? VSAQ है 2 marks का second और third question tailing of mercury लिखो बोलता. So this is the important VSAQ also. So in this property, what is tailing of mercury? थोड़ा डिटेल से लिख लेना आप. Mercury is white colored, shiny liquid and meniscus liquid, does not sticks on the glass tube. When ozone is passed through the mercury, it loses its properties and that is converted to the mercurous oxide and sticks on the glass tube. So this is the third one and fourth one, how it reacts with the C2H4. ethylene से reaction है C2H4. C2H4 थोड़ा C2H4 को मैं ऐसा लिख ले रहा हूँ CH2 double bond CH2. So you see that ozone undergoes addition reaction with the unsaturated compounds. ओजोन का एडिशन होना है तो आपको कंडीशन है हाइड्रोकार्बन्स में डबल बॉन्ड रहना, कैसा भी, या ट्रिपल बॉन्ड रहना. सिंगल बॉन्डेड कंपाउंड से ओजोन कंबाइंड नहीं होता, एडिशन नहीं होता. तो द कंडीशन इज ओजोन का स्ट्रक्चर ऐसा है, समझिए आप, ये ऐड होना बोले तो आपको क्या होना बोले तो डबल बॉन्ड होना. ओजोन undergoes addition reaction with the unsaturated compounds. Here I am taking ethylene. Ozone undergoes addition reaction with what? Ethylene, and forms this compound, that is the cyclic intermediate CH2. Just I told you for the addition of the ozone 2 bonds are required. Just write down like this CH2 CH2 and ये ओजोन के 3 ऑक्सीजन में एक को ऊपर बिठा दो और बाकी के 2 को ऐसा नीचे लिख लो. So this is called as the cyclic intermediate, called as the ozonoid. It is called as the ethylene ozonoid. Ethylene reacts with the ozone, or ozone undergoes addition reaction with the ethylene and forms ethylene ozonoid. So this is the unstable one. It is dissociated in the presence of the metal zinc. That is also called as the hydrolysis. So this ethylene ozonoid dissociated and forms the, देखिए इधर से ये हिस्सा अलग हो जाता, इधर से ये हिस्सा अलग हो जाता. CH2O को मैं ऐसा लिख ले रहा हूँ, है CHO, इधर बाजू से आया, इधर बाजू से गया, इसीलिए I am writing like this. 2 has CHO, that is called as the formaldehyde. Formaldehyde is formed and H2O combines with the oxygen and gives the H2O2. So this is about the other property. Ozone reacts with the ethylene and forms the ethylene ozonoid, and that is dissociated in the presence of zinc and forms the formaldehyde, 2HCHO. This is the another important question in the question number 20. Yes, another one. Just I told you in each question, that means in the 19 I have given 3 important LEQs, and also in the 23 important questions are there, and also in the 21 all are name reactions I have given. So among 20 में जो आ रहे हैं, सो 3 important questions है, 2 important questions मैं समझा दिया, एक अमोनिया एक है और सेकेंड वन ओजोन के प्रॉपर्टीज है. Now then third question जो एग्जाम में आ रहा वो electrolytic preparation of chlorine. Chlorine, how chlorine is prepared electrolytically and how it reacts with the following. This is another important question in this. So I am explaining you about the preparation of chlorine by the electrolytic method. Generally for the preparation of the chlorine by the electrolytic method, Nelson cell method is used. Nelson cell method is used for the preparation of the chlorine. In this Nelson cell method, chlorine is prepared by using, this is the electrolytic method, by using what? By using the brine solution, aqueous NaCl solution. You see that I am explaining you in shortly. In the Nelson cell method, U-shaped this steel vessel is taken. This is the U-shaped vessel called as the Nelson cell. Inside of this, which is coated with the asbestos. Okay. Now this is the U-shaped vessel, acts as the cathode. A cathode कैसा काम कर रहा. Now next, inside of this vessel, brine solution is taken and one graphite rod is kept in this. इसमें graphite rod लगा देते हैं. इसको क्या बोल के बुलाते हैं? एनोड बोल के बुलाते हैं. देन ये पूरा इंस्ट्रूमेंट को एक आयरन टैंक में लगा देते हैं. So this is about the diagram. U-shaped glass vessel is called as the Nelson cell. This acts as the cathode, inside of which brine solution is taken, and one graphite rod is fixed in this. This graphite rod is acts as the anode, and this steel vessel acts as the cathode. ओके ये डायग्राम थोड़ा आप ऐसा रख लो, यहाँ प्रोविजन है हाइड्रोजन गैस जाने के लिए. दिस इज अबाउट द डायग्राम. फिर एक बार रिपीट कर रहा हूँ. नेल्सन सेल मेथड के अंदर इलेक्ट्रोलाइट दिस इज द इलेक्ट्रोलाइटिक मेथड. Nelson cell method is the electrolytic method. Chlorine is prepared in this method by the electrolysis of NaCl solution. By the electrolysis of NaCl solution, by using the steel vessel as cathode and graphite anode, following cell reactions are takes place. These are the cell reactions takes place. Inside of this, following reactions are takes place. You have to remember this equation. You have to write these reactions in the electrolytic method. 2NaCl that is dissociated and forms the 2Na plus 2Cl minus. Okay, it is called as the ionization. Ions form हो रहे हैं. पहले इलेक्ट्रिसिटी पास होते ही ये ब्रेक डाउन हो जाता है, Na प्लस और Cl माइनस लिबरेट होते हैं. देन उसके बाद में एट एनोड, एनोड के पास कहाँ है भाई एनोड? यहाँ पे है एनोड के पास, ये एनोड है. एनोड रॉड के पास क्या होता है? 2Cl माइनस जाते, 2Cl माइनस. क्लोराइड आयंस जा रहे हैं वहां पे, क्लोराइड आयंस जाके वहां पे इलेक्ट्रॉन्स को दे दे रहे हैं. इसीलिए इसको क्या बोल के बुलाते हैं? लूजिंग ऑफ द इलेक्ट्रॉन इज कॉल्ड एज द ऑक्सीडेशन होता. एट एनोड ऑक्सीडेशन टेक्स प्लेस एंड Cl2 gas 2Cl minus gives rise to Cl2 plus 2 electrons. This is the reaction takes place at anode. And at cathode before going this Na plus ions जाने से पहले वहां पे है. सो वाटर मॉलिक्यूल रिड्यूस होता है. H2 undergoes reduction means taking of the electron is called as the reduction. At cathode a reduction takes place. At cathode a reduction of water molecule takes place. 2 H2O 2 electrons. As a result of that you will get the 2 OH minus. OH minus आ रहे हैं भाई, और यहाँ पे H2 गैस भी लिबरेट हो रही. ये जो भी H2 गैस लिबरेट हो रही इसके प्रोविजन से बाहर चले जाती. नो देन वहां पे Na प्लस आता, फिर उसके बाद OH माइनस से कंबाइन होता. फिर एज अ रिजल्ट ऑफ दैट व्हाट इज फॉर्म? सोडियम हाइड्रोक्साइड भी फॉर्म होता. ये पोर्ट से सोडियम हाइड्रोक्साइड निकल के कंटेनर में आ जाता. नो नीड टू राइट ऑल दिस थिंग डिटेल इन डिटेल. Just you have to write this this procedure. No need to write all that procedure in detail. Just you have to write the principle like this, which I am telling you. When the electricity pass through the NaCl aqueous solution, following cell reactions are takes place. As a result of that, at anode chlorine gas is liberated and that is collected, and at the cathode H2 and NaOH is formed. This is about the principle in the preparation of chlorine by Nelson cell method, that is also called as the what? Electrolytic method. I think you might understood this. Next properties of the chlorine. How chlorine reacts with the following. आवाज आ रहा मेरा क्लियर ही है? आ रही आवाज क्लियर ही है ना? क्लियर ही है आवाज आ रही मेरी? So first reaction with the water. How chlorine reacts with the water? H2O is the formula. How it reacts with the water? See here, I am writing the H2O plus Cl2 or Cl2 plus H2O. What is going on at here? Chlorine combines with the water, that dissolves in water and forms the chlorine water, that is also bleaching agent. Chlorine water is a mixture of HCl and HOCl. Direct भी लिख सकते हैं आप इक्वेशन है तो, ऐसा भी लिख सकते हैं. This is called as the chlorine water. तो इससे HOCl फिर से डिसोसिएट हो जाता. HOCl डिसोसिएट हो जाके फिर क्या फॉर्म करता? HCl प्लस नेसेंट ऑक्सीजन को रिलीज करता. उसीलिए ऑक्सीडाइजिंग एजेंट कैसा काम कर रहा. सो दिस इज द फर्स्ट वन. It dissolves in the water. It means what? I am explaining you about the properties of chlorine. Chlorine dissolves in water and forms a mixture of HCl and HOCl. That is called as the chlorine water. This is the reaction with the water, first one. And the second one, how it reacts with the NaOH, sodium hydroxide, called as the caustic soda. Here two conditions are there. Chlorine reacts with the dilute, cold and dilute NaOH. What is the reaction takes place? Cl2. ये Cl2 जो लिखे ना भाई, ये 2 आ तो साथ ही क्या करो 2 NaOH लिख लो. Cold and dilute NaOH से react होता. Cl2 reacts with the cold and dilute NaOH. Cold and dilute NaOH. Cl2 plus 2 NaOH gives rise to what are the products formed here? NaCl. Sodium chlorine से combined होता है NaCl. And another one you have to mention, that is NaOCl आता है NaOCl. Okay, sodium hypochlorite बोलते हैं इसको. Sodium chloride and sodium hypochlorite is formed. Now then the remaining is H2O. This is the first condition. Chlorine reacts with the cold and dilute NaOH and forms the NaOCl and NaCl. And the second condition, that is chlorine reacts with the, you have to take the 3 moles of Cl2. Chlorine reacts with the hot and concentrated 3 to 6 ना बताइए तो इसीलिए ये 6 लिख लो 6 NaOH. And what is this condition? I am taking this hot and concentrated NaOH से chlorine react होता. And ये 6 में से आप क्या करो 5 को NaCl बना दो 5 NaCl. And at here you will get this one NaClO3 sodium chlorate, and ये आता sodium chlorate आता. When the chlorine is treated with the hot and concentrated NaOH, NaCl NaOCl3 sodium chlorate बोलते हैं इसको plus 3H2O, it is formed. This is the reaction with what? Sodium hydroxide. The first one is reaction with water and second one is reaction with sodium hydroxide. Now then third property that is asking that is reaction with NH3 ammonia. How chlorine is reacts with the ammonia? See, very simple reaction. I am writing this ammonia like this NH3. NH3 है ना भाई, NH3 लिख लिया मैं. ammonia. Ammonia reacts with the chlorine. 3Cl2 ले लो, ये 3 आ रहा तो 3 लिख लेना. यहाँ पे याद रखने के वास्ते बोल रहा हूँ मैं. NH3 plus 3Cl2. अब NH3 की जगह क्या लिखना है भाई? NaCl3 लिख लेना. ये कंबाइंड हो रहा ना, दोनों के बीच में रिएक्शन हो रहा. Ammonia combines with the chlorine. Ammonia reacts with the chlorine and forms the NCl3 plus what is the remaining thing? That is 3HCl is left. This is the reaction. If ammonia is not in excess, this reaction takes place. अगर अमोनिया एक्सेस में ले लिया भाई मैं NH3 है, ज्यादा ले लिया आप, तो आपको ये याद रखना है 8NH3 लिखना है. 8NH3 प्लस वंस अगेन वही 3Cl2 यूज कर लीजिए आप. 8NH3 प्लस 3Cl2. सो यहाँ पे क्या फॉर्म होने वाला है? यहाँ पे N2 गैस लिबरेट होती, साथ में एक सॉल्ट फॉर्म हो रहा 6NH4Cl अमोनियम क्लोराइड प्लस 3Cl2 लिख लिया ना. तो what is formed? What is the remaining thing? This is at here N2 gas is liberated. N2 gas is liberated. This is about the reaction of the excess ammonia. Excess quantity में अगर है तो ये रिएक्शन होता, N2 गैस लिबरेट होती. अगर सफिशिएंट है, एक्सेस है तो ये होता. सफिशिएंट क्वांटिटीज है तो आपको ये फॉर्म होता, NCl3 फॉर्म होता. If ammonia is not in excess, you will get the NCl3 and HCl. If ammonia is in excess, you will get the NH4Cl and N2 gas is liberated. This is about the reactions of the chlorine with the ammonia and water and NaOH. This is the another important question. इंशाल्लाह ये 3 क्वेश्चन से एक क्वेश्चन आपको एग्जाम में आता, नेक्स्ट एग्जाम में. So I am explaining you about the question number 19 beta. 19 in the question number 19 which are important, दो बिट्स बना रहा क्वेश्चन नंबर 19 में. A bit, write the important postulates in the collusion theory. Collusion theory. And the B bit, second one is the galvanic cell. So ये दो क्वेश्चंस आ रहे हैं, दो बिट्स आते. LQ फॉर 8 मार्क्स, इसमें से 4 मार्क्स कोल्यूशन थ्योरी के पोस्टुलेट्स पूछता, गैल्वानिक सेल पूछता. कभी तो भी कोल्यूशन थ्योरी टोटली 8 मार्क्स के लिए पूछता. 8 मार्क्स के लिए पूछे तो आपको 8 postulates लिखना है, अगर ऐसा बिट्स बनाया तो एक 5-6 postulate लिख के छोड़ना है. So I am explaining you this first question in the 19th one. 19th में जो important first question है इसको समझा रहा हूँ मैं, collusion theory के postulates है. So this theory is proposed by the scientist Arrhenius to explain the speed of the reaction in gaseous molecules. Gaseous reaction की speed को, velocity को समझाने के वास्ते ये theory propose करे. कौन propose करे? Arrhenius propose करे. तो वो इंट्रोडक्शन वगैरह जरूरत नहीं है, खाली इंपॉर्टेंट पॉस्टुलेट्स याद रखिए. इन द इंपॉर्टेंट पॉस्टुलेट फर्स्ट वन देखिए, थ्योरी कोल्यूजन थ्योरी है, उसीलिए तो यू हैव टू रिमेंबर दिस थिंग, कोल्यूजन्स आर नेसेसरी फॉर द फॉर्मेशन ऑफ प्रोडक्ट. दैट मीन्स once again I am repeating this first postulates, collusions are responsible for the chemical change. Collusions are responsible for what? For chemical reactions. This is the first postulate भाई, पहला postulate important है. Collusion, दो मॉलिक्यूल आके टक्कर खाना, उसको बोलते हैं collusion. Collusions are responsible for the chemical change और chemical reaction. वो भी कैसा टक्कर खाना? प्रॉपर ओरिएंटेशन में आके. ये भी एक वर्ड जोड़ देना आप, थोड़ा प्रॉपर ओरिएंटेशन में. इधर चले जा रहा, वो उधर चले जा रहा, ऐसा नहीं, दोनों आके प्रॉपर ओरिएंटेशन में टक्कर खाना. That is the first postulate. Collusions are responsible for the chemical reaction. Colloidal molecule should be in proper orientation. Then collision between them gives the product. This is about the first postulate. Once again I am repeating. Simply आप collisions are responsible for the chemical reaction, ये भी लिख सकते. Colliding molecule should be in proper orientation. इसके साथ में ये जोड़ देना. So this is about the first postulate. What is the second one in this? पहली बात तो हो गई, इंट्रोड्यूस कर दिया हमें. कोल्यूशन की वजह से केमिकल रिएक्शन हो रहा. कोल्यूशन हुआ, टक्कर हुई मॉलिक्यूल्स के बीच में, कोल्यूशन हुआ तो केमिकल रिएक्शन होता. Collisions are responsible for the chemical reaction. Colliding molecule should come in proper orientation. This is the first postulate. And second one in this is what is the second postulate? जो भी collision हो रहा वो ठंडा collision नहीं होना. Colliding molecule should possess some energy, proper energy रहना, उसको threshold energy बोलते हैं. ठंडे collision से product नहीं आ रहा. Colliding molecule should possess certain minimum amount of energy, then only product is formed. मतलब इसका ठंडे collision से नहीं होता, colliding molecule थोड़ा दूर से टक्कर खाना है. Colliding molecule should possess certain minimum amount of energy, that is called as the threshold energy. That molecules which are having that minimum amount of energy, threshold energy, and the colliding with each other gives the product. That is the second postulate. Once again I am repeating, colliding molecule should possess certain minimum amount of energy, then only product is formed. Colliding molecule should possess certain minimum amount of energy. Colliding molecules should possess certain minimum amount of energy, then only product is formed. Then only product is formed. Then only product is formed. That is called as what? Called as threshold. Called as threshold energy. इसको underline कर लेना, important postulate है ये. So this is about the second postulate. First one is collisions are responsible for the chemical reaction. Colliding molecule should come in proper orientation. Second one, collision between the molecule we should possess certain minimum amount of energy, then only product is formed, otherwise product is not formed. Colliding molecule should possess certain minimum amount of energy, then only product is formed. That is called as what? Threshold energy. That is the second postulate. Now third postulate, what is this? You have to see this beta. जरा ये देख लेना आप. एनर्जी ऑफ द जनरल मॉलिक्यूल यहाँ डाल रहा हूं मैं, ये जनरल मॉलिक्यूल्स है, ये एनर्जी प्रोफाइल है. एनर्जी ऑफ द जनरल मॉलिक्यूल इज वेरी लेस, बट द रिएक्शन होने के वास्ते क्या होना भाई? इतनी एनर्जी होना है. इसको क्या बोलते हैं भाई? ये थ्रेशोल्ड एनर्जी बोल के बुलाते हैं. थर्ड पोस्टुलेट जरा और करिए. ये एनर्जी ऑफ जनरल मॉलिक्यूल है, ये कौन सी एनर्जी है? थ्रेशोल्ड एनर्जी है. यही पोस्टुलेट बनाना है आपको. एनर्जी ऑफ द जनरल मॉलिक्यूल इज वेरी लेस व्हेन कंपेयर्ड विद द थ्रेशोल्ड एनर्जी एट द जनरल कंडीशन और एट एसटीपी. दिस इज द अनदर पोस्टुलेट. आपको समझ में आया होगा. एनर्जी ऑफ द जनरल मॉलिक्यूल इधर उतार रहा हूँ, थ्रेशोल्ड एनर्जी इधर डाल रहा हूँ मैं. ये पीक है, ये थ्रेशोल्ड एनर्जी. थ्रेशोल्ड एनर्जी मतलब इतना एनर्जी रहता है जो मॉलिक्यूल प्रोडक्ट्स देते. अब सो दिस इज कॉल्ड एज, क्या बोल रहे हैं बोले तो ये थर्ड पोस्टुलेट में मैं बता रहा हूँ. एनर्जी ऑफ द जनरल मॉलिक्यूल इज वेरी लेस व्हेन कंपेयर्ड विद द थ्रेशोल्ड एनर्जी एट एसटीपी. दिस इज अनदर पोस्टुलेट. देन फोर्थ पोस्टुलेट देखिए बेटा, द एनर्जी डिफरेंस, इन दोनों के बीच में डिफरेंस भाई, ये एनर्जी ऑफ जनरल मॉलिक्यूल इतना है और ये थ्रेशोल्ड एनर्जी इतना है. तो इन दोनों के बीच में जो डिफरेंस है ना, डिफरेंस बिटवीन दी थ्रेशोल्ड एनर्जी एंड एनर्जी ऑफ द जनरल मॉलिक्यूल इज कॉल्ड एज व्हाट? एक्टिवेशन एनर्जी बोल के बुलाते हैं इसको, एक्टिवेशन एनर्जी. So this is another postulate. What is the activation energy? Activation energy is nothing but the energy, threshold energy. Difference between the threshold energy and energy of general molecule is called as the activation energy. तो एनर्जी ऑफ जनरल मॉलिक्यूल इतनी है, फिर थ्रेशोल्ड एनर्जी कहाँ से आती है? नेक्स्ट पोस्टुलेट में बोला जाता. व्हाट इज द नेक्स्ट पोस्टुलेट? जो ठंडे कोल्यूशंस है ना, देखिए एक्टिवेटेड मॉलिक्यूल्स कैसा फॉर्म हो रहे हैं इसके बारे में बोल रहा हूँ मैं. ये छोटे छोटे मॉलिक्यूल्स जो ठंडे कोल्यूशंस टक्कर खा रहे हैं ना, एक की एनर्जी एक को ट्रांसफर हो जाती. एक्टिवेटेड मॉलिक्यूल्स मतलब थ्रेशोल्ड एनर्जी है, सो मॉलिक्यूल्स कैसा फॉर्म होते हैं? ठंडे कोल्यूशन से फॉर्म होते. So activated molecules are formed by the collision between the general molecules. जनरल मॉलिक्यूल्स के बीच में जो कोल्यूशन होता उसकी वजह से एक्टिवेटेड मॉलिक्यूल्स फॉर्म होते. एक्टिवेटेड मॉलिक्यूल्स के बीच में अगर टक्कर आ गई तो क्या फॉर्म होता बोले तो प्रोडक्ट फॉर्म होता. दिस इज द अनदर पोस्टुलेट. नो नेक्स्ट पोस्टुलेट, सिक्स्थ वन इज, व्हाट इज दैट पोस्टुलेट? ये जो प्रोडक्ट फॉर्म हो रहा है, एक्टिवेटेड मॉलिक्यूल्स कैसा फॉर्म हो रहा है ये बोला मैं. और एक नेक्स्ट पोस्टुलेट क्या बोले तो ऐसे कोल्यूशंस बहुत होते हैं. 100 कोल्यूशंस में 90% ऐसे कोल्यूशंस होते हैं, और 90 अबव ऐसे कोल्यूशंस होते हैं. एक 5 to 10% ऐसे कोल्यूशंस होते हैं. वो नेक्स्ट पोस्टुलेट बनाना है आपको. So what is the next postulate? Sixth one is, what is the sixth one? General collisions are very more in number, or the activated collisions are very few in number when compared with the general collisions. In short, once again I am repeating these postulates. First one, collisions are responsible for the chemical reaction. Colliding molecule should come in proper orientation. Second one, colliding molecule should possess certain minimum amount of energy called as threshold energy, then only collision between them gives the product. This is the second one. What is the third postulate? Energy of the general molecule is very less when compared with the threshold energy at the STP. Now next one, fourth postulate, the energy difference between the threshold energy and this energy of general molecule. Difference between the energy, threshold energy and energy of general molecule is called as activation energy. Next postulate, activated molecules are formed by the collision between general molecules. Next postulate, these collisions are very few in number when compared with the general collisions. These are the 6 postulate. Remaining postulate I will explain tomorrow, inshallah.